Welcome back, everyone. We have an update from Ideal Power Inc. It trades on the NASDAQ under the symbol IPWR. It's a developer and innovative provider of its broadly patented bidirectional semiconductor power switch. Happy to welcome its CFO, Tim Burns. Welcome back to the conference today, Tim. What's your update?
Thank you, Anna. Last update, I really focused on how solid-state switchgear and energy and power, so industrial markets, we're going to really drive our revenue ramp and get us to profitability. For this update, I'd like to take a little bit deeper dive on solid-state circuit breakers and also give the audience an update now that we've published our 2025 milestones. So first, if we look at solid-state circuit breakers, really there's a need for solid-state circuit breakers because of the growth in things like renewables, energy storage, EV charging, DC sources being added to the grid. This requires a pretty significant investment, both from the industrial and utility side on the infrastructure. And it's really because these DC sources need faster circuit protection solutions. Solid-state circuit breakers or semiconductor-based circuit breakers operate more than 100 times faster than electromechanical breakers. This eliminates arcing, which is very important for safety and also the safety of the downstream equipment. Electromechanical breakers have contacts that wear. Solid-state circuit breakers do not have physical contact, so there's improved reliability from these systems. And then also, if you utilize semiconductors, you add the functionality of programmability and diagnostic capabilities, so you can really have a smart grid. If you move from there on why solid-state circuit breakers to why B-TRAN-enabled solid-state circuit breakers, there's really a few reasons. So first, it's ultra-low conduction losses. So typically, solid-state circuit breakers have not been adopted in wide scale because there hasn't been a semiconductor solution with low enough conduction losses. IGBTs and even silicon carbide MOSFETs don't really offer the low conduction losses that you'd like to see from a solid-state circuit breaker. So B-TRAN with its ultra-low conduction losses is really an enabling technology, and also the fact that it's inherently bidirectional, where you can reduce the number of devices required for a given breaker rating is also very important to make solid-state circuit breakers much more cost competitive. And then because of the lower losses, there's much less heat that needs to be generated. So you can really have a lower system cost. So B-TRAN really enables smart, efficient solid-state circuit breakers with lower system costs. Moving on to our 2025 milestones, which is something that we announced since our last update. We set several milestones for the year for the investment community. The first is to secure the next phase of our development program with Stellantis. This is something that we actually just recently met with Stellantis and their global production teams. We're expecting to be able to announce something here in the coming months. A second milestone is to complete the deliverables in the first half of this year related to our first design win, which we announced back in December. So we're well on track to complete those deliverables. The third milestone is to really leverage that first design win to capture additional design wins and custom development agreements. And those will really be the precursor to the revenue ramp that we're expecting in the second half of the year. So our next milestone, following up on that, is to start that initial sales ramp in the second half of the year. We think we're in really good shape. We expect that first design win to result in actual sales here later this year, and we're expecting to capture additional design wins, as I had mentioned, that will also contribute to that sales ramp. We're also looking to increase the current rating of our products. So from a customer perspective, this is relatively invisible. There's no change in the form factor of the product. It's really just improving the performance and how much current that our current products can handle. So it's a win-win for both us and the customer, and will have no impact on the time it will take for customers to adopt our technology. And lastly, late last year, we'd announced that we had started third-party automotive qualification testing. Here in 2025, we look to complete that testing. And even though we don't necessarily need it for automotive purposes here in 2025, because that's a little bit longer-term market for us, these are the most stringent codes and standards that we'll test our semiconductor devices against. So this will really go over well with the industrial customers, is that it'll give them much more confidence in our technology and the reliability of our technology if we can pass these tests that go above and beyond what's required for industrial products. So that's a quick update of a couple things that have changed here in the last few weeks. Happy to answer any questions that the audience has.
Wonderful. All right. Thank you, Tim. Yeah. Can you talk about anything happening with the design win customer or in the market buying behavior recently, or Q4 in particular, that makes you feel different about starting the revenue ramp up in the second half of 2025?
Yeah, I would say if anything, it gives us more confidence in the revenue ramp. We know at that first design win, their timetable is very consistent. They want to have a product here mid-year that they can start selling to their customer base. So we're on track there. We also expect there's a lot of interest generated by getting a first design win. So I think it's really going to help with some of the discussions and engagements we have ongoing with some very large players in the market that also could contribute to that ramp here in the second half of the year.
And can you talk about how complementary your technology is with the design win customers' products, especially the expected contributors to start your ramp revenue?
Yeah, so this gets back to really what I was saying about solid state circuit breakers. They were evaluating our technology actually against silicon carbide MOSFETs. And they realized that one, our conduction losses are much better. It's just inherent to the architecture itself. And also they could use less devices. So they're saving in cost, one, by avoiding the 3 to 5 times more expensive silicon carbide options, but they're also reducing the number of parts. So it's even a bigger cost savings versus silicon carbide. So for us, it's a situation where we're working with them to develop the product. Obviously, the solid state circuit breaker design itself is theirs, but we're providing that core with the semiconductor device. And we're actually using the same box that they had already designed when they were looking at silicon carbide solutions. So our technology can easily fit in that box. Particularly given the fact that there's less devices involved. So that's going really well. They've told us that these are customer projections, but they expect the first year of sales could translate to literally hundreds of thousands of dollars revenue for us. And if you take that a step further, they said the second year of sales, could be over $1 million for us just from that first product. And we're expecting that over time, they'll develop a family of solid state circuit breaker products at different ratings.
Wonderful. Michael asks for you to talk a little bit about you've mentioned in the past earnings calls, you were able to reduce the size of the B-TRAN. When you go to the new size, will this hamper OEM's progress having to test a new size?
So it won't. So what our plan is right now is not to change the packaging for this initial change in die size. So it'll still be for us, a cost reduction activity because we're getting more usable die out of the same size wafer. We're getting over double the number of devices. But just so we don't impact customer adoption, we're actually not going to change the size of the package. So from a customer looking at the device, it will look the exact same. It'll just be the die inside that package is actually much smaller.
And Ross wants to know, what part of your chips have IP protection?
So it is pretty broad. So it is the architecture itself is patented. So just like IGBT is an architecture or a MOSFET is an architecture, B-TRAN is an architecture. And we actually have patents on the architecture itself. We also have patents on how do you control a double-sided device. We actually have some manufacturing related, some drive circuitry related patents as well, some application specific patents. So we have now, it's over 90 issued patents, and it's very broad in terms of coverage.
Our viewer Tice says, you state the solid state switchgear market SAM is $1 billion. Is that ideal power SAM, or since you are asset light, would you take a portion of that SAM?
Yeah, the IGBT market's actually much bigger. So that's our specific addressable market based on our technology, where we fit best, where it's not commoditized IGBTs that are unidirectional devices, where the only factor that matters is cost. So yeah, we've broken down the market based on a market study we had conducted for us and looked specifically where B-TRAN would have a competitive advantage, and that's represented in our SAM, both for the solid state switchgear market and the other markets that we show in our investor presentation.
Bruce says motor drives have been mentioned as a target market segment. Do you currently have any active participants in your test and evaluation program seeking to deploy your devices into motor drive applications?
So not yet if you're talking specifically about industrial motor drives. So that's, if you look at our investor presentation, that's actually the third box, one of the longer term opportunities for us. That's, I would say, a more cost competitive market. It's much more about reliability, where they want proven runtime. So for a new technology, they're much slower to adopt. So as it relates to industrial motor drives, that's one of the markets that we think will be great for us longer term, but is not something that will contribute to us getting to cash flow break even into profitability. That will really be the other industrial markets, things like solid state switchgear, EV charging, renewable energy, energy storage. Those markets will really be what contribute here over the next 12 to 18 months in terms of revenue generation.
Nick wants to know, how close are you to reaching commercial yield levels at each fab?
Yeah, I'd say we're a little bit further ahead with the first fab that we announced in Asia, which makes sense. They've been qualified for 3 or 4 quarters longer than the fab in Europe. I would say in the semiconductor space, it is an ongoing process. So you're always trying to figure out something else to improve to bring up your yields. We're actually very happy with the yields from the Asian fab, and we're very close to getting to those levels here with the European fab. So we'll have 2 fabs here in the near term that are ready for production, ready to ramp to production, and really support the revenue ramp we're expecting starting in the second half of this year.
And Lindsay says, since the last time you were on, can you talk about new customers or increased distribution since you last presented?
So in terms of distributors, we're still working with the same 3 distributors. It's Richardson Electronics here in the U.S. We also have 2 Asian distributors, one in Japan and one in China. They're actually performing very well for us. They're introducing some very large companies to us, so we have new engagements that we'll talk about more on our call here coming up next week. But in terms of customer engagement, I'd say it's nothing but picked up since we announced our first design win, and we'll provide investors with a much more in-depth update here next week.
And Sean asks, does your product benefit the quantum computing market?
So it is not directly. I would say where it really fits in well is if you look at data centers and the uninterruptible power supply systems and the circuit protection required for data centers. It's not a memory device. This is a high power device that you'd see in those type of applications, which things like data centers are obviously going to be growing as a result. That gives us a very good opportunity. It also fits in kind of that third bucket of a little bit longer term for us, similar to industrial motor drives, but it is a great opportunity for our technology and something that could probably be served by our SymCool IQ, which we just started taking orders for here late last year.
And Kurt asks, is cooling an issue with your chips since they work on 2 sides?
So we do have double-sided cooling, but the big advantage of our chips is the losses are so low. So losses are what result in heat, right? So if you can have much lower losses, you can have less complex thermal management systems. You need less area to dissipate that heat. You can have smaller heat sinks, those kind of things. So for us, our technology really provides an advantage over the other semiconductor technologies in the power space.
All right, Tim. Well, we are out of time. We've got some more questions for you, but we'll send them to you so you can answer on your own. Thank you for this great update. We appreciate you.
Thank you. Appreciate it. Thank
you. All
you,
right, everyone. We'll be right back.